Good morning, student. Okay, up to now we are studied last topic, that is the momentum. Okay, we are studied momentum is simply what, product of mass and velocity. Also we are studied the two laws of motion, okay, that are derived by the Sir Isaac Newton. First law of motion is every object continues in its position of rest or position in motion up to if externally unbalanced force is not applied on that object. Okay, that is the first law. Then we are studying second law. The rate of change of momentum of an object is directly proportional to applied force. Okay, F is equal to ma. That equation we are also derived in the last lecture. Okay, now today we have to see Newton's third law of motion, that is the last law of motion. So first of all, directly go towards the statement of this law. We have to see what is action and reaction force. We know force. Okay, force is a what? Simply it is a very basic quantity we have to apply on object if you want to change in that object. Okay, if you want to move or if you want to stabilize an object, if it is in motion, then we have to apply force on that object. Okay, due to force what happen, that are always we also see in some last basic lectures. Now actually force is what? Simply force is a reciprocal action between two objects. Forces are not always present alone. Okay, forces are always present in pair. Okay, if we apply somewhat force on an object, then equal and opposite force also that object apply on us. Okay, that's simply called as a reciprocal action between two objects. Okay, first of all, forces are not exist alone. Forces are always present in pair. Okay, force is what? Reciprocal action between two objects. Reciprocal action means what? Simply if I want to push that wall, okay, if I apply 100 Newton force on that wall, then same and opposite, okay, 100 Newton force simultaneously that wall will apply on me. Okay, so equal and opposite force will be that object apply on me. Okay, so action force is simply what? I told you one example. I have to suppose push wall, then if whatever the force I apply on wall, okay, that force is simply called as a action force, and simultaneously equal and opposite force that will be applied by wall on me. Okay, that force is called as a reaction force. Okay, simply we can say both are equal, but their signs are opposite, their directions are also opposite. I want to pull that wall, then that is the action force, but equal and opposite force will that wall apply on me, that is nothing but the reaction force. Okay, so action and reaction force are act simultaneously. Okay, so no one force exists alone in the nature. Forces are always exist in the pairs. Okay, so that are the action and reaction force, that are also called as a reflection reaction between the objects. Forces are nothing but reflection action. Forces are what? The reflex action between the objects. So now from that Newton derived its third law of motion. The statement of that third law is every action forces has an equal and opposite reaction force which act simultaneously. Okay, what? Every action force, okay, whatever the force we apply on particular object, then equal and opposite reaction force. Okay, equal and opposite reaction force which act simultaneously, that much equal amount but opposite force that object will apply on us. Okay, this is the statement of Newton's third law, that based on action and reaction force. Action force means what? Simply whatever the force we apply on a particular object, and reaction force what? After the application of this action force, equal and opposite same force apply on that object, okay, by that particular object. That is nothing but the reaction force. So this action and reaction forces are always existing pair. Okay, not one force exists alone, forces are always existing pair. Okay, and this is the statement, every action force has equal and opposite reaction force which acts simultaneously. Both forces are act simultaneously, action and reaction force. Okay, so what are the examples of Newton's third law? Okay, so example of Newton's third law is, if we are playing cricket, okay, then if we hit ball by a bat, okay, at that time what happened? As we hit the ball by bat, then what happened? This speed of a bat goes on decrease, okay, because ball applies equal and opposite force on a bat. Okay, actually ball's direction is this, and if we move bat in this direction, then what happen? We resist ball to go in this direction actually. Okay, so due to what? Ball's direction change, but due to the ball's direction change, it also applies equal and opposite force on a bat. Okay, so due to that what happen? Bat's motion is slow down, or speed of a bat is slow down. Okay, that is the one example of Newton's third law. Then another one is example is launching of satellites. Okay, so we know that satellite, the rockets are moved in upward direction very fast. Due to the what? Due to the gases are exhausted from downward side. Due to the pressure of that gases, that satellite goes in upward direction, means it gains direction due to the existing gases. Okay, so that is also the example of Newton's third law, equal and opposite reaction. Okay, so this is the statement you have to remember, that is important. Every action force has equal and opposite reaction force which acts simultaneously, and you should know what is action and reaction force. Action force means what? Simply whatever the force we apply on a particular object, and reaction force is what? Equal and opposite force that which apply by object on us. Okay, that is the reaction. That is law of conservation of momentum. Okay, we are already studied momentum. Momentum is simply product of mass and velocity. Now we have to see conservation. I think in the last year we studied law of conservation of energy. Okay, conservation means what? Simply conservation means remains same, it does not change. So we have to see law of conservation of momentum. Conservation means what? Here remains same, so the conservation of momentum is takes place, means momentum remains same, that is the unchanged. How? That we have to see by using some mathematical operations. Okay, so look at here, suppose we have to consider two objects. Okay, object A and object B. Okay, now object A has mass m1 and its initial velocity is u1. Okay, what? Object A has mass m1 and its initial velocity is u1. Then second object B has a mass m2 and its initial velocity is u2. Okay, object AB, mass m1, m2, and their initial velocities are u1 and u2. Now from that we have mass and velocity. Okay, mass and initial velocity, mass and initial velocity. If we know mass and velocity, then by taking their product we can find out easily their momentum. Okay, so initial momentum of A will be equal to m1 u1. Okay, m1 is a mass and u1 is a velocity of object A. So initial momentum of object A is what? Mass into velocity m1 u1, and initial momentum of object B will be mass m2 and its velocity u2. Okay, so m1 u1 is the momentum of first object A, and m2 u2 is the momentum of second object, that is B. Now we have to consider that two objects A and B are collide with each other. Collide means what? Interaction between takes place, and these two objects are collide with each other, then somewhat interaction will be happen in that two objects. Okay, so after collision, what happen? One object will apply force on other object. Okay, here we say F1 be the force applied by B on A. Okay, whatever the force applied on A after collision by B, that is nothing but the F1, and F2 be the force on B due to the A. So what happen here? Two objects are collide with each other and they apply force on each other according to Newton's third law. Okay, so after collision they apply force on each other. Due to that, what happen? Acceleration produced in both objects. Due to the production of a acceleration, their velocities are again get changed. Okay, so v1 will become velocity of this first object A, and v2 will become velocity of this second object B. Okay, what happened? What we have to consider here? That two objects of initial momentum m1 u1 and m2 u2 are collide with each other, and due to their collision, what happened? They will apply force on each other, and due to that force, what happened? Acceleration produced in both the object. Okay, so momentum of A after collision. Okay, I already told you after collision what happened? Acceleration produced in both objects, their velocity will get changed due to the collision. Okay, if velocity get changed, then their momentum will also get changed, because momentum is what? Product of mass and velocity here. So momentum of A after the collision m1 v1, and momentum of B after collision will be m2 v2, where v1 v2 be the velocities of object A and B after collision. Okay, so we know F1 is the force applied by B on A. Okay, whatever the force applied on A at a time of collision, okay, and F2 be the force on B due to A. So both objects A and B apply force on each other at the time of collision. But we know these forces are equal and opposite. Whatever the force applied on object B, that will be equal to force applied by B on A. Okay, so we can say F2 will be equal to F1. Okay, because both forces are equal but opposite, that is why we give here negative sign. Okay, but we know according to Newton's second law, F is equal to what? Ma, where F2 is what? Force applied on B, that is the second object which having mass m2. Okay, so that will be F2 will be equal to m2 a2 will be equal to F1. F1 is what? m1 a1. Okay, F1 is what? Force on A, and F2 is what? Force on B. Okay, that you have to remember. So M2A2 will be equal to minus M1A1. So we know this A2A1 is what? Acceleration after collision, before collision, and we know acceleration is simply what? Final velocity minus initial velocity upon time. So A2 will be V2 minus U2 divided by T. Okay, and A1 will be V1 minus U1 divided by T. Okay, we know V minus U divided by T is nothing but the acceleration. That adjustment we made here. Okay, that also you have to remember. So our equation will be become TT present on both sides. So this TT will get cancelled over here. So remaining part is M2 V2 minus U2 will be equal to minus M1 V1 minus U1. Okay, so we have to multiply all the terms present inside the bracket by these terms. Okay, so M2 V2 minus M2 U2, okay, will be equal to minus M1 V1 minus minus become plus M1 U1. Okay, so that will be, we have to rearrange the equation here. Okay, here we have to take M1 V1 M2 V2 will be equal to minus M1 V1 plus M1 U1. Okay, so we have to rearrange the equation. If we will move this term in left hand side, okay, so it will become positive. So M2 V2, if you move this on left side, that will be become positive. So M2 V2 plus M1 V1 will be equal to M1 U1 plus M2 U2. This term you have to move in this side. So again this will become positive if we will go to the right hand side of equation. So M2 V2 plus M1 V1 will be equal to M1 U1 plus M2 U2. Okay, so this is what? M2 V2 plus M1 V1. This is nothing but the, look at, V is what? Velocity after collision, and U is what? Velocity before collision of both objects. Okay, V2 is what? Velocity of second object after collision, which having mass M2, that is the B, and V1 is what? Velocity of first object after collision, that is object A of mass M1. So this is the total momentum, total final momentum after collision. Okay, because V is the velocity become after the collision, and M1 U1 plus M2 U2 are the initial momentum. Look at here, M1 U1 and M2 U2 are the initial momentum. So if you find out after collision or interaction between two objects, there is always conservation of momentum takes place if external force not apply on that two object. What? Look at that here. This is the total final momentum. Magnitude of total final momentum will be equal to magnitude of total initial momentum when two objects interaction between two objects takes place, and if no external force apply on both objects. Okay, so this is called as a law of conservation of momentum. Conservation means simply what? Conservation means what? Remains same, does not loss in a momentum takes place if the interaction between two objects takes place. Okay, you have to see, that is recoil velocity of a gun. Okay, according to Newton's third law, we see forces are always exist in a pair. Okay, action and reaction forces does not exist alone. Now we have to consider one example, that is if we fire one bullet from a gun. Okay, so what happen here? We have to consider a mass of a bullet is M1 and mass of a gun is M2. Okay, mass of bullet is M1 and mass of gun is M2. Now initial velocity of bullet and gun, initially both are at a rest before firing. Okay, gun and bullet are rest, so there initial velocity of bullet and gun will be equal to 0. Okay, then initial momentum of a gun and bullet. We know momentum is simply what? Product of mass and velocity. They having gun having mass m1, bullet having mass m1, gun have mass m2, but their initial velocity is how much? 0. So the product of mass and velocity will become to 0. Okay, that is the initial momentum of gun and bullet, that will be 0 because their initial velocities are 0. Now after firing, velocity of bullet will be v1. Okay, after firing, bullet will get somewhat velocity, and that velocity we call v1. Okay, and we know action and reaction forces. As gun goes in forward direction, then that will be applied force on gun. That is why gun will move in backward direction. Okay, that is why we have to hold gun in shoulder when we are firing. Okay, because that always recoils. Equal and opposite forces are there. Okay, so that a backward motion of a gun after firing the bullet is simply called as a recoil. Okay, so here what happen? Gun get recoil with a velocity. That velocity we call v2. Okay, v2 is what? Recoil velocity of a gun, and v1 is what? Velocity of a bullet. So we know total initial momentum will be equal to total final momentum, that we already see in last topic, that is the law of conservation of momentum. So here total final momentum, total final velocity of the bullet is v1 and final velocity of gun is v2. So product of mass and velocity of both bullet and gun that we have to take, that will be the total final momentum. So m1v1 be the total final momentum of a bullet plus m2v2 be the total final momentum of a gun. So this is the total final momentum, and we know total initial momentum will be how much? Total initial momentum of gun and bullet will be equal to 0. So we know both are equal. So m1v1 plus m2v2 should be equal to 0 because m1v1 and m2v2 are the final momentum after firing, and 0 is the initial momentum because initially both are at the rest. Their velocities are equal to 0. That is why 0 is the momentum at initial condition. So both momentums are equal according to law of conservation of momentum. So we can see here m1v1 plus m2v2 will be equal to 0. So we have to find out this recoil velocity, and we call here gun recoils with velocity v2. So that v2 we have to find out actually here. Okay, so just we have to put this v2 on left hand side, or the remaining part we have to shift on the right hand side of the equation, and if you move all the terms on the right hand side, then we will get equation v2 will be equal to minus m1 by m2 into v1. This is called as the equation of recoil velocity of a gun. Okay, so this equation you have to remember because sometimes problem asks on this equation. So this is the recoil velocity of a gun. Recoil means what? Simply backward motion of a gun when we firing a bullet from a gun. Okay, so such a way that all the theoretical part of this chapter is complete. Okay, if you have any doubts in any theoretical part of this chapter, then please ask me or comment in this video. Okay, so in next lecture we will see some problems. Okay, thank you.